In this video, we're going to see how we can use Microsoft Excel to carry out a simple t-test relating to a hypothesis about the average wages within the UK economy. Now, we're going to be using data from the 2019 UK Labour Force Survey, and we have a sample of 100 individuals. And we're going to see how we can test a particular hypothesis relating to population average wages. Now, before we dive into Microsoft Excel, let's think a little bit about the theory.
So suppose we wanted to test the hypothesis that average wages in the population was equal to £650 per week against the alternative that average wages was not equal to £650. Well, what we need to do is, first of all, construct an estimate of the population average. And the standard estimator that we go to for the population average is the sample mean. And if we take 100 observations of xi, then we can construct an estimate of the population average through our sample mean. Now we know if our observations are independent and identically distributed, then the sample mean will be approximately normally distributed, centered on the expected value of x, with variance equal to the variance of x over n. So in principle, if we know the variance of x itself, we can standardize our test statistic to be normally distributed with expectation 0 and variance 1. So if we have a sample mean x bar, we subtract the expectation of x and divide through by the standard deviation or the standard error of our estimator, which is the square root of the variance of x bar, or the square root of the variance of x over n, then that will follow a normal distribution with expectation 0 and variance 1. The problem is we do not know what the variance of x is, and so we're going to need to estimate it. We know that s squared, which is equal to 1 over n minus 1, times by the sum of the squares of the deviations of the observations of x away from the sample mean, that is an unbiased and consistent estimator of the variance of x. Now, in principle, what we could do is we could take this s squared and substitute it into our standardization formula, but it emerges that if we use s squared, this expression will no longer follow a normal distribution, but instead it will follow a t distribution. So if we take x bar minus the expectation of x and divide through by the square root of s squared over n, that will follow a t distribution with n minus 1 degrees of freedom. So when we're trying to test a hypothesis, we're going to need to appeal to critical values from the t distribution.
So we can use formulae that we've already seen in Excel to calculate our estimate of the population average. And the estimate of the population average is just going to be the sample mean, and we can calculate that by using the formula equals average, and then we'll select our data. We've got 100 observations here, so it's in cells A2 to A101, and that gives us an estimate of that population average of £661.45. And similarly, we can find an estimate of the variance of x using the formula equal var.s. Remember that var.s is the formula to find an estimate of the population variance based on a sample from that population. And again, we're selecting cells A2 to A101. And that gives us an estimate of the variance of x equal to 137,741.44. So let's write down our key data. Our sample mean is equal to 661.45. Our estimate of the variance is equal to 137,741.44. We also know that we've got 100 observations, so we can construct an estimate of the variance of the sample mean by dividing through the estimate of the variance of x by the number of observations. So we can rewrite this using equals, and then we'll select the estimated variance of x, we'll divide through by the number of observations, and that gives us an estimated variance of the sample mean equal to 1,377.41. Now remember, we were interested in testing the hypothesis that the expected or population average of x is equal to 650 against the alternative that E of x is not equal to 650. Now, in order to test this hypothesis, we need to construct our t-statistic. And in order to construct the t-statistic, we take our estimate. Our estimate of the population average is 661.45, and we subtract our hypothesized value, which is 650, and divide through by the estimated standard error of our sample mean, which is equal to the square root of our s squared over n. So this is the square root of 1,377.41. Now we can do all of this calculation within Microsoft Excel. So first of all, let's find an estimate of the standard error of the sample mean. We know that our estimated variance of the sample mean is 1,377.41. This estimated standard error is just the square root of 1,377.41. We can do this in Excel by using the formula equals SQRT. That calculates the square root. We select the cell that we want to find the square root of. That estimated variance is in cell D4, and we get an estimate of the standard error equal to 37.11. Finally, we can construct our t-statistic, which is just equal to, and make sure you use the brackets here, our estimated population average, which is 661.45, minus our hypothesized value, which was equal to 650 here, divided through by the estimated standard error, which gives us a t-statistic equal to 0.31. Now we can specify this using the formula by saying equals t.inv.2t. That's indicating that we've got two tails to our test. Our significance level is 5%, so we're going to use 0.05, and we've got 100 observations, but we lose 1 degree of freedom because we're estimating the population variance, so we'll have 99 degrees of freedom, and we can find the critical value as t.inv.2t in brackets 0.05 and 99. And that gives a critical value of 1.98. Our t-statistic is 0.31, which is a lot smaller than the magnitude of this critical value. Therefore, it lies within the non-rejection region. So we fail to reject the null hypothesis.